In this session, the very talented Xiaohan Zeng and myself set up an EBSD run of 10 samples that ran simultaneously. So that means 10 large area maps on 10 different samples, all run at once without stopping. Or at least that was the intention. I've done 3 in the past in a row with another student, but this was the most we'd ever done on this system. So I thought I would make a video of it. It might be of interest to some other people. We ran this scan on a Thermo Apreo SEM at the University of Manchester. It was equipped with an Oxford Instruments Symmetry 2 CMOS detector, and overall the scan took about 4 days to run. So the samples were deformed titanium. This is Ti 6 weight % aluminium, 4 weight % vanadium. And we used a high current, but used a slow scan speed, just because the samples were heavily deformed, but we were unsure whether it would affect the indexing or not. So Xiaohan made the decision to run at a slower speed to ensure that we got good indexing, so that took longer. But the scans still run pretty fast in the end. Not as fast as the system can go, but still faster than a standard CCD EBSD detector could. The samples were about 2 by 1 centimeters. So we did montage scans of the entire area for each individual sample. And these were adhered to these little aluminium platforms that fit in this special stage that's designed for the Apreo SEM, which has multi-stage functionality. So the full setup took us about 2.5 hours. And here are the points I thought might be of interest to others. Lovely.
Yeah.
So I guess we need to have a discussion about how we're going to set this up. So how confident are you that your samples are flat? I'm assuming they probably are, knowing your sample prep. So to save us some time on the setup, I reckon we can use 1 focus point per sample. What do you think?
Sorry, can you repeat again?
So we've got 10 samples. We're going to need to do, it's a montage map for each, right?
Yeah.
Are you doing the whole sample for each?
Yeah, whole sample.
So we need to put in, we need to store the coordinates of all 4 corners of all 4 samples. But if your samples are flat, then we don't need to adjust Z every single time.
Yeah.
And we can just use 1 Z coordinate for each sample.
Yeah, I see.
Yeah. So we'll start with the one that's most central.
Yeah.
And we'll get the focus set for that, and then we'll just adjust Z up and down for each different position, sort of thing, as we go along. But only for, we'll move to the center of each sample, adjust Z to get the focus, and then do all 4 points, and then move on to the next one, and then the next one, and then the next one, and the next one. Cool. I have no idea how long this is going to take. But I imagine you'll get pretty well practiced at this, because you're going to end up doing this at least, 10 times over the next year?
Yeah. I still have a lot of sample.
Right, so we want to just check in this, the notes I made last time. So we want to do 65-degree tilt, 30 mil working distance, seems pretty good. Seems like a smart idea. Right, so camera insertion distance 5 mil out from second stop position. So I guess we can. I've put 159.6, so I guess we can just bring it into about 150, set up all of our points, and then we can nudge it as close as we can once we know which the highest Z position is. Because we should, we'll save all the points before we even bring the camera in, and then we can look through them and we'll know which one has the highest Z position, and we can use that as like the danger zone sample, and then we know that we're not going to hit anything. So what of your what samples do we have? I assume they're all your old ones.
Yeah, all rolled sample. There's 7 sample rolled to 75% reduction. There's 3 sample was rolled to 50%.
Right.
Yeah.
Different temperatures, all the.
Different temperatures.
How many temperatures are you doing overall?
9 temperature.
9.
Yeah. So I have so many samples. So now we need to find the sample in the corner.
Well, we need to, if you've got your alignments all done, then we need to get to 30 mil working distance, and then we need to get tilted. Because we know from what we did last time that at 65 degrees tilt, you can move the holder no matter where you want, and it's not going to hit the pole piece.
Okay. So now we tilt it?
Yeah, I think it's worth doing 10 degrees at a time though. Just to be safe. Looks like a tiny metropolis, doesn't it? Little city of samples. It's also nice to watch the reflections.
Okay.
Right. So we should still be on that center sample, right?
Let's see. Always found it hard to focus after that tilt.
Yeah, I normally just hunt around for a piece of dirt. Because there's always one piece of dirt on your sample. You can never get rid of all of it, no matter how hard you try.
Okay. I can't even tell which sample I'm focused on. There are 3 on the.
Well, if we were on the middle sample before we tilted, we should still be on it now.
Yeah, I think it's the middle sample. But if it is the other two, I can't tell.
Well, we're definitely on the center line. You can tell that by looking at the CCD camera. So maybe it's worth just going across to the left and across to the right, just to make sure we find another sample in either direction. One of the things Jack was talking about doing was having a positional setup designed for the multi-stage holder. So what we do is we put the holder in, adjust it to a known angle, and then we would save all the positions of all the holders, and then you can export that list and then re-import them into the position bit. So then we can move to each one very quickly. We'd obviously still have to do all four corners of the sample, but it would save all this clicking around.
Yeah.
And give us some confidence that we know where we are. Oh, look at the CCD.
Oh, no.
Right. So we're at the edge.
Oh.
What didn't it like there? Did it not like it couldn't go left any further or up any further? Yeah, so it's
Couldn't go left.
Yeah, I think you've just gone right to the edge, so I think you can still go up. So I think what you're seeing there is actually the edge of the holder.
Yeah, I think so.
Because last time I couldn't get there. Maybe we've set it up slightly different. Right, so we're not adjusting focus here, are we? We're adjusting Z.
No.
So we may as well remove the WD focus link.
Remove this.
Yeah, so where you linked your working distance to your focus before, right click that button and say unlink.
Right click?
Oh, no, not that one. No, keep that on. That's just for stage rotations. That one. And then unlink Z to forward. Sorry, I always say working distance to focus because I think that's just a remnant from other microscopes. Okay. I mean, we've moved a lot, and that's not that out of focus.
Yeah.
Oh, yeah. I've noticed this glitch before. When you unlink, you just get this big boost in contrast. I don't know why it does that. Cool.
So why we unlink it? So now I change the working distance. It won't change the Z.
Yeah. So you unlink it because to transfer all of your different Z coordinates across to Aztec, you need it to be not linked to the focus. Because when you change Z, you change the focus with it if it's linked.
Yeah.
Right? And we don't want to do that. We want to keep our focal plane the same and move the samples either down or up into it as you change for each sample. Yeah? So then we can transfer all those coordinates across to Aztec, and then Aztec will be like, right, okay, this sample, we move this Z distance to bring it here. That's why we do that. And we can't, even if you have one sample that's in focus, if you have 1 point saved on the microscope positions that's linked Z to forward, it's going to confuse it. So we need to unlink before we do any positions. Is that all right?
Also, if I link them, so if I I click what? That didn't change anything. So if they keep linked and I refocus on every sample, which means they have different Z.
Yeah.
So we're trying to prevent the change in Z direction so it won't hit the EBSD detector.
No, the main problem that this all stems from is that Aztec can't control the focus on the microscope. So when we're saving all the individual points, ideally we'd want it to go, right, we want this focus, this stig, this, other bits and pieces. But Aztec is designed to work with all the different microscopes, so they will have different ways of focusing. But the one thing that it always controls is the X, Y, and Z coordinates. So we keep the focus point the same and move Z instead because we know that Aztec can do that.
Okay.
But we can't expect them to design software that can speak to every microscope in existence so that it can control the focus. I believe that's where that stems from.
Okay.
I'm sure some other smarter people will correct me, but the main point is that Aztec doesn't control the focus, only Z, so we have to rely on changing Z and not the focus. All right.
Okay. I think I understand, but yeah. I'm not sure.
The problem we have with the detector is if we go from one sample to another, and say we've got a sample here, and the detector's here, and then we want to look at this sample, so then we move it down like this, but then we change the Z quite a lot, and it comes up like this. This bottom sample could hit the bottom of the EBSD detector by compensating for the Z height here.
Yeah.
And that's why we need the samples to be as close to the same sample height as possible, so that we're moving as little as possible in Z.
Okay. I think I understand. Yeah. So what we do now?
So yeah, we need to find something to focus on, and then we change in Z, right?
Okay, so it's only.
Yeah. We've done this before together, right? Where we shift in Z and do different focus points.
Yeah.
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 So then you just to change Z, you just use the bar on the right where it says stage Z, and then it's got a big slider and it says down and up.
Oh, this one.
I mean, it looks pretty good,
Yeah.
I don't think you're going to get much better than that. See if there's something, a bit of dirt that's a bit more flat. Because that's one of those, like, oxide columny things, it looks like. Yeah, that little bit there would be great.
I think looks good.
Yeah, looks good. I'd go for that. And then find the 4 points and save them. We should name these as we go along as well, so we know what's what. Maybe a sort of 1-1 system is simplest. And then on to the next. 1 down! Woohoo!
It's gonna take an hour.
Yeah, but add up the time it would take to do them individually, 1 on, 1 off. I'm also keeping a close eye on that CCD camera. So I think it's best to have 2 eyes on this. So if you keep an eye on the focus, I'll keep an eye on the chamber. Getting there, that'll be good enough.
Yeah.
Yeah.
Okay.
Using this method, you never get the focus amazing. You know, we compromise, so we gain a very convenient way of doing scans, but at the same time, we have to make some sacrifices on, you know, quality of our scans. Yeah, that's fine. I mean, yeah, maybe adjust it a little bit, but it's not too bad, is it?
Yeah.
So, you've prepared these really well. How did you do the sample prep in the end? Did you just sort of time how long you were grinding things for? Did you use the automated?
No, I grind it by hand.
You did these by hand?
Yeah.
And you've got the heights this close together? It's incredible.
Yeah.
That's incredible. You know, I've only just noticed. I thought this holder was 12. It's only 10. So of course you've done 10 samples. I just had it in my head it was 12. So I just remembered 3 by 3, and then I've just realised it's, yeah. And how, why is it taking me that long to realise? Surely it should have been a red flag when you've done 10 samples and not 12. Oh man. Absolute idiot I am.
Oh, that's a millimeter. Oh.
Hey, so I was right. My eyes aren't failing. But I mean, to be fair, the first 7 were, you know, a manner of microns out, so.
Oh yeah, the first 7 is rolled to 75% reduction, so I prepared them together, and the last 3 I prepared them before, so they are at the same time.
That's interesting. Yeah, I mean, there's no way you were going to do 10 in the same day.
Oh, I can.
I didn't say you couldn't. I just wouldn't want to. That's a boring ass day.
Well, I did 9 one day because I rolled at night temperature.
Ugh.
So I always did 9 in one day.
How long does it take you to do 1?
To do 1, it doesn't take long. So I do 9. 9 sample takes about 4 hours.
Ugh. I can hack 1 or 2. After that, I take a very, very long break. I'd rather do like an hour or 2 every morning for a week than do 1 solid day of it.
Well, I'm fine with sample prep. It's much easier than writing my report. I think it's okay. I'm moved to the limit. I cannot go to the age of the sample.
Yeah, I thought that might be the case.
Okay.
We'll just have to get what we can. So this is one things that we need to. I think that we're going to pass back to the manufacturer, just because like I think this is the first time they've tried something like this. So it's a very development microscope.
That's not enough area, I think.
Well, let's scan what we can.
Okay.
Because I mean, your samples. What I would have said before is move the samples to the top of your little aluminium platforms, but they're too wide, so they have to go in the center, don't they?
Yeah.
Maybe there's a workaround we can do. Maybe attaching, something on those aluminium stubs with like a lip, and then we can lift them out and move them up above the stage or something like that. If you know what I mean. Maybe that's a workaround we can use in the future. I mean, 8 full sample scans is not half bad.
Yeah.
Did that last point save?
Oh no. What?
Do you just need to scroll the bar down?
No, it didn't save.
I was worried that it might not be able to save all the points. Oh no.
No.
Right, we've reached the limit.
Okay.
So what we'll do, I've got a pen and paper because I was worried this might happen. So I'm going to write down the points. And then while we're setting up on Aztec, I'll just read them out to you.
I can write it down.
Oh, okay. Yeah, you could do it that way. I'm just trying to be useful. Just sat here doing nothing, really. Shush, cat. Not now.
Okay. All done.
Right. So I think, I don't know about you, but if we don't check all of these points multiple times, I'm going to have nightmares. So what I think we do now is I don't think we need to check all 36 points we've stored. 36? 9 times 4, 36. But I think one from each, but also we need to keep an eye on which one is the highest Z. I'm assuming it's sample 7.
No, 7 is the lowest one.
It's the lowest one, okay. Either way, we need to find the one that has the highest Z coordinate, because that's going to be our most dangerous sample.
Okay, 8 is the lowest one, so which one is the highest? Oh,
it saved them up there. We can do it. Oh, yeah. It's saving them alphabetically, not chronologically. Absolute idiots. We should.
Oh, yeah, understand.
We should have realised that. That's funny. That's really funny. Well, I guess you can just, yeah. Oh, dearie me. That's so obvious now I think about it.
Yeah.
I love it if the SEM manufacturer watches this video at some point. They're going to be yelling at the screen. You idiots! It's just alphabetical.
So funny.
Dearie me. Lovely. Right. Okay. And then, yeah, go to, but hover over stop. Because this is going to be terrifying.
Okay.
You ready? Go! Be brave!
Oh. Stop. Okay. Wow.
Nice! Oh, man. My blood pressure is far too high. 22.7. Yes, Cat, I know you're hungry. I'll get to you in a minute, one thing at a time. Oh, we've got 22.8.
It's the first one. 26.
I'm writing down the different Zs.
Third one. Yeah, the third one.
Oh, that one was particularly horrible.
Yeah.
Just because we've got that slight angle between the CCD camera and the stage, it looks like we've just ploughed right into it, doesn't it?
Yeah.
But we're fine. We're absolutely fine. 22.9, that one.
Yeah. That one is the highest one. Oh. 2.9. The fourth one, 20.9. 22, 23, almost 23. Oh, this one is 23.
Yeah, we've slowly drifted up, haven't we?
Oh.
So it looks like, the full drifting range is about 400 microns. Oh, we haven't got to sample 7 yet, have we?
Yeah. Sample 8 is the lowest one.
Oh, sample 8, okay.
So this one is sample 7, 22.9.
Well, that's actually fine. It's within the same as number 4. Yeah, so the full drift range is about 1.4 mil.
I can see it changed the thing.
But we're fine going that way. You know, that's moving away from the camera. I'm happy with that.
Yeah.
And, you know, that sort of drifting distance away from the camera is probably not going to affect your patterns that much. You know, you can pull a camera out, 2 to 3 mil without having any drastic effect. The one thing where it's going to matter is where you've got a lot of deformation.
Yeah. 9 plus 1.
Thinking about it, it might be worth, as sort of an additional sort of checks, setting up the actual EBSD on sample 8, because that's going to be the farthest from the detector. So we have the exposure at its at the point where the strength of the signal will be the lowest, if that makes sense. And then we can check the sample that's the highest to make sure that it's not oversaturating the camera when it gets to it.
Yeah.
That makes sense.
Makes sense. Move to sample 8.
So going by this, I think sample 5 is our most dangerous, because that's 23.14.
Yeah. Sample? Okay, it's sample 8 now.
Sorry, I missed that. I was just booting the cat out.
So now it's on sample 8. I'll move to sample 5.
Yeah. Maybe the lower point, so 3 or 4. So sample 5, bottom left or bottom right corner. I don't think it's going to make much of a difference, but,
Yeah.
Maybe I'm being too cautious.
Cautious is good.
Yeah.
Okay.
Aztec time?
Yeah.
So what are we aiming for? Are we going for highest resolution possible, smallest step size, or are you going for maximizing your indexing rate?
I want to use those I used for my other sample, which is 10 micron step size.
Makes sense.
And sensitive speed.
Okay. Yeah, I mean, if we maxed it out, you could end up with 640 megapixels worth of data if you wanted to.
I'll choose this.
Do you rotate the directions on this because it's easier for MTEX?
Well, I always choose the rotation.
Right.
But I can change it with Crystal or Channel 5 later.
Mm.
Okay. Camera. Okay.
Right, so it was 159 the insertion distance I used before.
Yeah.
So maybe push it in and keep an eye on where we're at. But because I know we've got to do a lot of, we've got to push the camera down a lot in elevation. So maybe go to 156.
Oh, no.
I'm not sure if that's going to move slowly or quickly.
Okay.
So I guess move 2, but be prepared to hit stop quickly. I guess the other way you could do it is...
Should I use I hit stop?
Yeah. Easiest way of doing it, isn't it?
Okay, I'll stop here.
So maybe we get move to the middle of a sample and get the patterns up first, and then we start playing around with the elevation. Oh, we need to pick a magnification as well.
Magnification 700.
Yeah.
Okay.
I mean, your samples aren't too big, so that should be fine. I mean, we're gonna have to use the calculator in a bit anyway to work out what we can do in the time allotted.
Oh, oops.
Oh, you do get nice FSD images on your samples. It's a lot of beta. Or, well, secondary alpha.
Yeah, so this one is 5.
Yeah, it's definitely a smart idea going for sensitivity when your samples are deformed, even if they're deformed hot.
So what should I do now?
Click around, get us a pattern.
Yeah, it's definitely not in the center.
Yeah, if you right click the camera image, it should be able to I think right click it. Oh yeah, it's not even picking up the pattern center, so it's completely off the screen. So we need to start moving downwards. So I guess drop it 1 millimeter at a time, and we'll just keep going down until it looks like. Yeah, you should unpause the CCD camera as well so you can see what we're doing.
Oh.
Cool. Yeah, I think we're going to end up at -13 again. You've got easy clearance, so I think we're good on that front. But my worry is that the patterns are so weak because we're still quite far out. So, but we got loads of space to bring it in. Yeah, we're fine. Yeah, 13 was right. There you go. Right. Should we work on bringing it in a bit? So the sample we're worried about is 8. And that is the one on the CCD camera. That's the third row closest to us, isn't it?
8.
That's
Yeah.
No,
yeah.
wait. Is that the highest? Is that the highest one?
Yeah, this is the highest one. Yeah.
Yeah. So we've moved to sample 5, so we're at the highest Z working distance. So now we need to move down. We need to move the stage so that the highest sample, i.e., sample 8, is in a position to collide with the camera. If that makes sense.
Yeah, makes sense.
So we leave Z as it is, and then we just move manually on the secondary electron camera. Just move. Hang on a minute.
You mean move manually to sample 8?
Yeah, because we can't use the saved position because that will move in Z. You see. So we want to keep Z where it is, but move the highest sample right next to the EBSD detector, and then we'll move the camera in as close as we can get it where we're comfortable, and then that will be our most dangerous position, and then we know that if that's safe, then everywhere is safe. Yeah? So
why can't I just go to, I know it will move a bit on that position, so by worrying the 1 millimeter move will hit the camera, hit the detector?
Yeah, so I don't know exactly how the stage is going to move during this scan, because I can never keep track of which one it will do first and this and that. And we just want to know that if we move where the stage is at its highest and that sample is next to the camera, then we know completely that the whole movement of the stage throughout the entire process is not going to hit the camera, no matter what it does.
Yeah.
That, to me, is the safest way of making sure. I will bet you any money the engineers will tell me that is over the top, because they will know exactly how the stage moves. But because I don't want to take any risks. And I don't want a new detector coming out of my project budget. Or yours.
Okay, so this is stopped now. So do I need to stop it in Aztec so I can see it?
Just hit off.
Okay.
And then you've transferred beam control back to the SEM.
Where is sample 5? Oh, sample 8. Sorry.
You might want to zoom. Yeah. Yeah, so that's the right way. So we just want to move that big sample so it's next to that bottom bit of the detector where the FSD detectors are.
I think it's this one. Is this one? It's this one.
Yeah, so keep going down. I mean, I'm not looking at the actual secondary electron image. I'm looking at the CCD. Right, so now that high sample is in a position that it could collide with the camera, right?
Yeah.
So what we're going to do, if we magnify the CCD image, so just click the quadrant and click F5.
Oh, yeah.
Yeah, and if you hit F5 as well, it's going to magnify it on the screen, so we just look at one quadrant and not all 4. Yeah. I think we're a bit far across as well. So that sample right at the bottom that we can see there, I think that's further away. So we could probably bring it closer a bit. But just so we get a better view, if you know what I mean. So if you go back,
we insert a bit. You mean make the EBSD detector more closer to the sample?
Yeah. So just sort of move the stage towards us in the CCD camera using SE.
No, I don't understand. Can you repeat again?
Yeah. So if you minimize the CCD camera again. Yeah, and then go to the SE and click right, I think. No, wrong way. Other way, sorry. So I'm watching that sample at the very bottom on the CCD, and I'm just moving that more in line with it. Again, this is probably over the top, so there's fine. Yeah, that's absolutely fine.
Yeah.
Actually, you can probably go down as well, now that we've moved it a bit. Yeah. No, I got it wrong again. Up.
So what we are looking now?
Right. Hold on, have I got this wrong? Can you, sorry, on the CCD camera, can you take the magnification off? Right, so 8 is the third row, isn't it? Yeah, it is.
What?
Yeah, it's got to be. Yeah, it's the right sample. Okay, we're good.
Yeah.
So, like, that's that sample right at the bottom now. That's sample 8. If we then move the stage up in Z, that would smack into the detector if we're not careful. But if you zoom up on it, we've got a good 2 to 3 mil that we can move the camera in.
Yeah.
Yeah, so if you go, yeah. Right, so now if we nudge the camera in sort of maybe 0.2 mil at a time.
Wait, I need to think about.
Yeah, take your time. No rush.
So now we are at 23 and sample 8 move in, say, so why we don't move the Z to 22 before we move the camera?
To 22?
I mean, so sample 8 has say in 22, 21.9.
Yeah.
So why we don't move it first? So if we focus on sample 8, it will more close to the detector.
What I'm worried about is while we're on hang on a minute, let me think. So we're currently at the highest stage position. So that's on target, isn't it? So if you go to actual on the stage tab, we're at 23, right? Yeah.
Yeah, 23, but sample 8 is 22. Wasn't it 22 the highest?
No. So, okay, just to make sure that we're on the same page here, when you've linked the focus to your working distance, the measure you get under Z is the distance from the pole piece to your sample. It's this distance here, right?
Yeah.
When you unlink it, Z is then measured from the bottom. So 0 in Z now would be the stage at its lowest point. And as we go up, we're moving the stage closer to the pole piece. So that's why when you've got it linked, there's the green arrow next to Z which points down, because that's the way Z is moving. So positive Z moves down when you're linked, but when you're unlinked, positive Z goes up.
Okay.
Yeah?
Okay, I'll see when I move the stage.
Yeah. Okay. Yeah.
Yeah. So we want to move the camera first.
Yeah.
So we step in 0.2.
Yeah, I mean, just safe increments, right? And then hit step in bit by bit, and it's just going to slowly nudge it in. And then I guess move it in as close as you're comfortable. I mean, none of this is comfortable, but...
Yeah. Because I didn't notice how close they are when I did the EBSD before, so I don't know how much I should move.
I mean, the one thing that's nice is that you've got that proximity detector on. So while we're moving in like little nudge by nudge, if it does touch something or get within, a certain range, it's going to immediately retract. So it's not, by doing this, we're not going to damage the detector no matter what we do.
Okay. Good to know.
Yeah. I mean, what are we at now? We're nearly at 159. I think 159 is a good place to stop. Let's have a look at our patterns now.
Oh no, we're not... I need to scan the new image.
And you'll need to move back onto a sample because we're not on the sample that the Z's set up for.
Yeah.
So you might, maybe just go back to one of your saved positions of sample 5. Hang on, which was the lowest again?
Oh.
Just reading my notes. 8. So if you click one of your stored points for 8, and when you click this, watch the stage, it will go backwards or down.
Sorry, what should I do now?
So if you click that 8-1.
Yeah.
And then hit go to, but if you watch the stage, it will retract, it will go sideways.
Oh, so the stage will retract.
Yeah.
Okay. I hope it's not going.
Trust me.
Oh, now I understand.
There you go.
Okay. So I thought it's gonna move.
Yeah. So realistically, when we scan the sample, it's not in any danger at all. The worry is when we're scanning other samples and the stage is near the detector that it moves up so far that it can hit it. That's the worry. But by doing this step where we maneuvered the dangerous sample into position and then set up the camera, we know now that there is no position that we've got stored that will hit the camera. Yeah. But of course we will be checking every single one of them. Just so I can sleep tonight.
I will get the image, this one.
Oh wow. Look how different it is.
Sample 8. Oh, sample 8, which I can't remember.
Oh, FSDs are so unforgiving for scratches, even when they don't make a difference.
Yeah. Okay, looks fine. Looks good.
Do you know roughly how fast you were running before on your other scans? in terms of the hertz?
So I did 2 frames,
Mm-hmm.
and it takes 11 hours. But I have 7 sample is smaller, a bit smaller than I did before. So I think it will take about 9 to 10 hours.
Well, should we calculate that? So we've
Yeah,
now got a rough speed. So it says 250 hertz. Sorry, you didn't hit your frame averaging, yeah. So 120-ish hertz.
Yeah.
When we're going at those sort of speeds, the acquisition doesn't make a big contribution to extra time. So we can probably assume 120 hertz and be fine. It's going to be 11,000 frames for the whole thing.
Yeah.
So we've got, okay, so this is Friday. Let's assume that we set it running at like, let's just say 1 o'clock because it makes life easier. And then we've got Sunday, Monday, Tuesday. When did you book it to? The whole of Wednesday, right?
Yeah, the whole Wednesday.
Okay.
There's 7 sample, 7 hour, 49 hours. There's now I got 3 sample, a little bigger.
Okay, so if we just give ourselves some wiggle room, because we're not gonna calculate this exactly, are we?
Yeah.
So let's just assume that we're gonna hit Thursday morning at 9 a.m. Let's just assume that. So we've got 1, 2, 3, 4.
So from
5 days plus 1 p.m. Friday to Saturday at 9 a.m., which is 21 hours. So that's 141.
Yeah, it's more than enough.
Was my math correct there? So let's say 140 divided by 10. We've got 14 hours of scan. So you can drop your step size if you want to, or we can, up the exposure time to try and get better indexing.
I'll just use 10 micron to keep every sample the same.
Okay.
I was using 10 before.
Should we see if we can increase the exposure time without oversaturating the camera? So if you turn the beam on.
Oh.
And just click on a point. Yeah, I wouldn't use the arrows. It does quite large bits.
So I restarted.
Just type in manually. So I think we were at 1.5 before.
Yeah.
Okay, and then just type in like 1.5, 1.6, etc.
Well, it doesn't change.
It changed. If you hit enter, it'll change it, but it's just not affected anything.
Oh.
So we're on quite a clean pattern at the moment, so we're not going to see much of a difference. But when we hit like a heavily deformed area, this will really matter. So just keep upping it until the camera starts to saturate.
What? Ooh. What should I do?
So just go 1.7, 1.8, etc. Yeah, see, that's when the camera starts to oversaturate. Do you see the difference?
Oh.
Yeah.
Yeah.
So 1.6 was the max.
Oh, yeah. Can see.
It just gives you a slightly longer exposure time, so when you've got those more diffuse patterns, you'll be able to give the software a better chance of detecting them.
Okay. But the speed doesn't change?
We won't know that until we run a test scan.
Okay.
So it says the acquisition rate of patterns is 126 hertz, but it doesn't take into account the processing or the time for each frame. But the mapping calculator takes into account the changes between the frames, so that's fine.
Okay.
So it actually says, do you see underneath where it shows the pattern here? No, if you go back to Optimize Solver, so where the pattern is, it says cycle time underneath.
Where is it?
So underneath the EBSD pattern, it says cycle time, and then analysis, detector, etc.
Oh, yeah.
Right, so if you click on a pattern on your FSD image, just so it's actually analyzing something. You need to hit auto at the top, so it auto indexes, yeah. Right, you see it's adding 0.2 milliseconds.
True.
So we'll now be at 1.52, I think 1.62, but that brings your indexing down a little bit. The best way of working out is just to run a scan and just look under the EBSD data, and it will tell you exactly how fast it's going.
Okay.
So if you just go acquire map and then just run a quick scan. Click the little clock in the left hand bar.
What?
Oh, doesn't matter.
Oh.
Doesn't matter.
Yeah.
So if you go under the EBSD tab on the data tree, and then right-click the EBSD data tab and go details.
Oh, it's here because I was trying to find this and I look at this detail, then it doesn't tell me the speed.
Yeah, you got to click the right tab. So it says about 114 hertz rather than 124 or whatever it was saying. So we can now put that figure into our calculator and know exactly how long it's going to take. Not exactly, but it's pretty damn close. So 8 hours. Ooh.
7 hours.
So the whole scan's going to take 70 hours plus whatever the extra size bits. So we've got loads of time to spare.
Yeah.
I mean, we don't have to use all the time.
Yeah.
So should we go forward with that?
Okay.
Okay.
Because when it's finished, I got other sample to do. I always have samples.
Yeah, well, there you go. You've got the time booked. You may as well use it, right?
Yeah.
Okay, so you're happy with the right magnification and all that? Your indexing is excellent. 97%.
Yeah.
Lovely.
It is 98.4.
Beautiful.
So now we can set up the...
Yeah, first of all, we need to bring up the little clock thingy. So if you go and then step size is correct, then maximize the frame. Before we start putting these maps in, we need to think about if there's anything we've missed. So maybe check settings at the top, because I think I had the EDS running on this. No, that's fine. Don't need any of that.
Yeah.
What's our frame width? 580. Yep, we're at the right magnification. Yeah. I can't think of anything else. So let's start putting maps down. So one by one, and then we just roll through each one of your 4 coordinates on Automate. Right, so maybe actually before we put all of these coordinates in, should we just run through all the coordinates on the SEM sequentially to make sure that we're not hitting the camera while we've got proximity detector on and Aztec isn't in the mix.
Yeah. So what's the error in the Aztec experiment position being complete with error state?
Say again, sorry. Oh, right at the bottom. Yeah, this is a glitch that's come up a couple of times. I don't really know what it means. I need to ask technicians.
Okay.
But just double check your beam shift to make sure it's still in the middle, because that's the one thing I know can make a scan drop out if you're not careful. It's on the top tab. Yeah, so our beam shift is still in the middle. As far as I'm concerned, there's nothing more we can do to make sure it runs correctly. So you've just cleared those errors, okay. I mean, actually looking at it, maybe our magnification's a bit high, because we're not filling that whole frame that well with 10 micron step size, are we?
Maybe
it doesn't matter. I'm just saying.
I think it doesn't matter because I did all my sample in this way.
Yeah. Okay, if you go back to the EBSD calculator a sec. This is just out of my interest, sorry.
Yeah.
Our total stage movements is 1 hour and 15 minutes. It's not too bad. But then, if you think about, we're doing 10 samples, so that's 11, 12 hours worth of stage movements alone.
Yeah.
So, like, just, in future, maybe one day of cutting down on the amount of time that you're using, you can use a larger, a lower magnification, and then you've got less frames and less stage movements. And then that just, you spend more time scanning than moving the stage.
Yeah.
I mean, absolutely fine to leave it for now. Let's not complicate things further. We're set up and ready to go. Let's just check these points.
If I'm using Tascam, I will definitely lower the stage movement time. But we have so many times on this.
Yeah, but that's not always going to be the case.
Yeah.
It's nice being on a new microscope when it's in the development stage. There's a limited number of users, but at Manchester, that's not going to last. Okay, let's go. One sample point at a time. Hit go to for each one, hover over stop, and pray.
Okay.
Again, the proximity detector's on, so if it gets within, like a few microns, it's going to stop everything.
Okay. Why it's not moving? Oh, yeah.
Nice.
Okay.
See, these are the safe ones because the stage at the bottom is nowhere near the camera. Oh, it don't look like it, looking at the ones at the top by the pole piece. Just where the angle changes. It's horrible.
So close.
Okay, decent clearance on the camera.
Okay.
Again, that was an angle thing. It just looked like it got super, super close. But it actually wasn't.
Yeah.
But again, we know we've got clearance, so we're fine. Okay.
Oh, it looks we still have 3 millimeter
Yeah.
between the sample and the detector.
Yeah. I mean, it's fine when that sample's being scanned by the detector. It's when, yeah, I don't know. It's again, it's just a lack of me not knowing how it's exactly going to move the stage. So for me, the safest way of doing it is to just imagine the worst possible position that it can be in. And then, even if it's very unlikely that it's even going to be in that position, if you've prepared for that, then there's no way any of the others can hit. Okay. And breathe. So you just line them up as you would normally. So
Yep.
map 1, map 2, map 3, all on the same site.
Okay, yeah, that's. I'll check it again.
Yeah, I triggered that thing to come up when I reloaded a map. Reloaded the stage positions on something else, so I don't know why it's doing it.
Yeah.
So yeah, just
I always got this.
Yeah, just click yes. We don't need to see that again. Lovely. Everything look familiar?
Yeah.
Good.
Everything the same. So now I add area or
You go automate again.
okay.
But I don't know whether do you want to name these or just leave them as area 1, 2, and 3. I'm not sure what notes you're keeping.
For this one, I know area 1 is sample 1.
Great, nice and simple. Like it.
Allow range. Alec.
Yeah.
So it says the position is out of the allow range.
Sorry, I skipped out for a second. And yeah, if you're on samples 9 and 10, this was one of my concerns. If you just go to each point and then nudge it up a little bit.
Okay.
I think it's when it's on the periphery, it doesn't want to take the chance because it's it's got to move there automatically. So if you just move it up a touch, it's much happier. So just on those 2 bottom points for samples 9 and 10. and then save that, and it should be okay with those.
How to get rid of this?
Has it saved both of them across? Why? Minus 55.7. And what was... Yeah, you might just have to go a bit higher. Still not happy?
Yeah.
Again.
Oh.
Just try something for me. If you just cancel that for now. Yeah. Discard changes. Now, if you reopen map 8.
Map 8?
Yeah, so if you just click the little pen to edit it. And then check the points on those. Okay, good. On one of the really old versions of Aztec, and I'm not sure if this is the problem with Aztec or its connection to the Syrian SEM. When you went out of the ranges, it then just got stuck saying everything was out of the range, and then you had to redo everything. I think it was a full rebuild on the Syrian then, but I was 99.9% certain that glitch had been fixed on later versions of Aztec, or it was just something specific to the Syrian. So that's not happening, so we're fine. So you can just resave area 8, and we can, yeah. We might just need to lose more of the bottom of samples 9 and 10 than we would like.
Okay.
So it might be worth doing this a little, well, yeah, we're just gonna have to work it out, what it'll let us do. I mean, it's probably just one of those things where they were making sure that the when Aztec was moving the stage, that it wouldn't smash it into the chamber corners or something. It'd just be a safety limiter, which is absolutely fair enough. You know, we need to keep things safe.
No.
Oh God.
I've moved a lot. Not a lot. I moved 1.5 millimeter.
We're just gonna have to keep shifting up. Hey, there we go.
Hey, yeah, it's. Well, so what's the problem?
I have no idea.
And I
try moving that one to 54.9.
Okay, that's fine. Move down. Okay, 55.
Right, so can you add that to that little Word document on the desktop? Just that y must be higher than minus 55. Just so we've got a note of it.
Okay. Wrong keyboard.
Okay, great.
Oh, the last one. Okay, all done. Shall we hit the run? Or is there anything I need to?
I don't know. Do we need to say a few words? pray to the gods of EBSD.
But I hope it won't ask me to do it again when I hit run.
It shouldn't.
I hope there's no any other error.
First, just check the settings button on automation just to make sure that there's nothing silly down. Yeah, turn off beam at end of run. Seems like a good idea.
Yeah.
One last thing. Do you want the proximity detector on or off?
On.
You're going to keep it on. Play it safe.
Yeah.
Yeah. Smart.
No, I never turned it off.
Yeah.
Well,
I think
it doesn't affect my sample.
No, I think if you're on a very very high resolution, I think it does affect it, but big step size is.
Yeah.
So I think we're good. Yeah. Punch it.
10 sample. Okay. I can hear it's moving.
Yeah.
A long way. Oh, looks good.
Yeah. Should we get an IPF color on so it's prettier? I think we're done.
Yes.
Now we wait 70 hours and pray. So the scan went well. We hit one unexpected hiccup where unfortunately Xiaohan had to go in and restart the scan on the SEM after sample 5. This is something we're now aware of and it won't happen again. But yeah, the scan went slow because of the concerns of misindexing due to the deformation in the samples, but they scanned with over 95% indexing, so we could easily have gone faster. So we were using a very high current for this scan, 51 nanoamps, and you could have easily run the Symmetry 2 detector at 3 kilohertz, which would have meant that we would have been able to do probably all 10 samples in about a day. So that would have been really excellent. So the next step is to try running the same amount of samples and run faster, and then see if we can do more samples. So next time we'll do smaller samples, but 2 on each of these aluminium platforms to take the number up to 20. And then, you know, these platforms are quite big. We could try smaller and smaller samples and then do more and more and more. And I guess the point is, how many samples is too many samples to run simultaneously?